Alright then, welcome back everyone. Let's solve first three tasks of the AtCoder beginner contest. I guess it's 434 if I'm not wrong. Yes, yeah, it's 434. And so about my performance, I was able to solve first three problems again. Yeah, sadly. So the fourth one, yeah, well, I got the approach again, but I couldn't code it. So I guess it's happening a bit too much now. I have to come up with a strategy to solve the fourth question in the contest time itself. So yeah, for that, sorry, but I'm working on it. Okay, so there's a lot going on right now. But yeah, let's go to each of the questions one by one. So first question, we are given two integers w and b, where w's unit is in kg, and this is this guy's weight. An object attached with n balloons will fly into the sky if and only if mass of the object is strictly less than n into b. So it simply means if you come here, just notice here. So this simply says that okay, what happened to my keyboard? Please work. Yeah, okay. So this simply says that you will fly if and only if your weight is less than n into b, right? So your weight has to be strictly less than n into b, and this now I guess all both of them are in the units are different, right? So this is kg and this is gram, but let's just convert it. Okay, let's just assume that this weight is also in gram. So I'll just multiply it with 1000. Okay, so unit conversion, let's just assume straight away. So we have weight and this, you can say b balloon weight in grams. This is w into 1000 grams. So a guy will fly only if w less than n into b. Okay, so that's pretty much it, right? So you just find me the n which satisfy this equation. So what is the minimum number of balloons? You just find me the smallest n such that w is less than n into b. Cool, makes sense. So this can be pretty simple, right? So what you have to do is you have to simply, your answer will be what? Can you just find me the, you can say n such that w is equal to n into b? That n will actually be equal to what? W divided by b, right? So I'll give some examples here. Let's say w was 10 and this was uh, b was, let's say, 2. So in that case n would have been 5, right? So n would have been 5. So in this case your answer is what? 5 plus 1, 6. But for example, if this was not a perfect multiple, then it would have been 3. So the answer would have been what? It would have been still, you can say, 10 divided by 3. What is 10 divided by 3? 10 divided by 3 is again 3, right? But what is your answer? Your answer is 3 plus 1, 4, right? Because if you have actually 3 balloons, then the weight will be 9. Like if you have 3 balloons, then here it will be 9, but weight is 10, right? So in both of the cases, your answer is simply w by b plus 1. That's what I'm trying to say. Yeah, I guess it was pretty simple. Just trace out some examples and then you will actually know. Let's just see the implementation here. So balloon details, let me expand this one here. Okay, yeah. So in both the cases, the answer is simply w divided by b plus 1, where I've just, you can see, converted both of them to grams. Okay, so this was a simple question. Let's move on to the second one, bird watching. Now this is an interesting one, right? Here, one thing was there about doubles, right? So I hope you took care of that. Otherwise, you may have gotten wrong answers. So what is this question? So there are n birds, and for each bird, we have a type associated among numbers 1 to m. Okay, and each bird also has a weight. Now what you had to find is you want to find the I guess weight, it's size, right? So for each bird there is a type which is defined like any of the numbers from 1 to m, and for each one of them there is also a size which is bi is actually 1 to 100 something, right? So this was it, I guess. Just give me a minute. Okay, all right. So for each bird, we have a type and size associated. So now what you have to find is for each of the types among 1 to m, you just tell me the average size of flying birds, right? So for each of the type from 1 to so on till m, you just find the average size of flying birds of type k. So this is actually very simple. What you can do is, you know that there are m unique types, right? So for each of the unique types, you just store, you can say, an accumulated sum of all the sizes, right? So you know that in the input you will be given what? AI and BI. So for every unique, you can say, number from 1 to m, which defines a type, you just store it, so you can say accumulated sum of sizes, and the count of how many times a type has occurred. In the end, your answer will be what? The accumulated sum divided by the frequency, right? So that's pretty much about this question. All that remains is you have to you can say keep care of the precision. So that we can do it very easily. Let's just see how. So yeah, see. Pretty simple. What you have to do is n and m, n being the number of words and m being the types that we have. Then I'll just go on and take the input. You see what I'm doing. For each type, I'm maintaining the accumulated sum and I'm maintaining how many times this type has occurred. So the input is defined like this, right? So whatever the type is and whatever the size is. So I'm taking that, fine. And then this is very clean code, right? You can observe. So what I'm doing is if this entry is not present in the map, I'm initializing it. So MP of type. So initially what it's going to return is total is 0 and count is 0. So if no entry is present, then initially you will get both 0, 0. But I'm also taking them as a reference. So what does it do? Whatever the size is, you add it to total and just increment the count. And these two are actually updated by reference inside the map. So yeah, so this is a very clean code. So after that, for each type you have, you can say the accumulated sum and accumulated count. So this is all you have to print actually. You have to print for each type. Val dot first is simply you can say the sum, and val dot second is you can say count. So this is actually the average size. It's just you have to take care of the precision, right? So for that you have to write this. So you have to set the precision to 12. So I guess the expected size was about 10 power minus 5, right? So just set it something like 10 or something. Just set it more than 5. But let's not for sanity, I've just set its precision to be 12 around. Okay, so it will be precise up to 12 zeros. And I guess you already observed I'm using here long double. Okay, so that's why this division works here. These are not integers. So LLD I have defined here. This is yeah, it's a long double or long double, whatever. So this is this question, and now let's see the C question, the flapping Takashi. Now this might look somewhat difficult, but it's not. Now what this question is saying is initially this guy is at some height h. Okay, this guy is at some height h, and at every second this guy moves. You can say will fly for you can. I guess it's given. He can change his flying altitude by up to 1 per second. It says that let's say if currently this guy is at height 10, he can go. He can either stay at 10, or in the best case go to 11, or come to 9, right? So can change this flying altitude from up by up to 1 per second. So it is somewhere between 0 to 1. So if it is, you can say in 1 second he travels 1 unit per second, then it will be from 9 to 10. If it is 0, it will be here. Or what else? If it is, you can say less than 0, let's say 0.5. If it is 0.5. So what I was saying is this guy can either descend, you can say descend up to 1 second, or ascend up to 1 unit, right? So 9 he can go to 10 or 8, right? So that's what this thing is saying. Okay, mota mota, that's what it means. And what else? So at time 0 he's at height h, fine. In other words, like they have defined this complicated math, but this is, you don't need to go about it. So I just explained you what this math means. Okay, initially is at height h, and then they have just explained the difference between height at some later interval. But this can be easily derived. Fine. So yeah, and then what you have to do is there are n goals regarding the altitude. The ith goal is to make the altitude at time ti at least li and ui, where you can say this li is less than equals to ui. So what is saying is initially you are at height h. Now after some time ti, so at t equals to 0 you are at height h. After some ti, can you be in some range, you can say li to ui. So they are just asking if you can be in some range li to ui. That's what this question is, right? Now yeah, so you are given t test cases and you have to solve each one of them. Okay, so how do you approach this one? This on the surface looks bit odd. There is some math involved here, but this is not that difficult as it looks. Let's collect all our observations, right? So let me switch to Excalidraw if I can open. Let's see. Yeah. So what this question says is you are initially at height, you can say h. Okay, sorry. So you are initially at height h at time equals to 0. Let me denote it like this. You are initially in this range. Okay, so it will make sense in a bit. Just stay with me. So initially you are at here at t equals to 0. Okay, cool. Now let's just for brevity, let's just say this is some 9. Okay, this is 9. So you know that in 1 second you can either go here, let's say 8, or in 1 second maybe you can come here to 7. Okay, so this you agree with me, or you can maybe decide to stay here as well. That's not an issue. So for 1 second what you can do is, so this is, you can say, let me bring everything here. Okay, so in 1 second so this is for t equals to 1. Okay, for t equals to 1 you can either decide to stay here, or maybe you can decide to come here, or if you decide to go down it, you can come here. Fine. So these are all the possible, you can say, intervals where you can be at 1 second. Now, can you write for 2 seconds as well? I guess you can, right? So if you are at here, in 2 seconds you can either come down to 9 again, or you can go one step above. So in 2 seconds maybe you can decide to come here as well. So in 2 seconds maybe so I guess this should have been 10, right? Anyway, so you would have noticed it. But anyway, then this would have been 11. This would have been 11. And then you can either decide, so this would have been 8, right? Okay. Then similarly, you can either decide to go down here as well. Right. So this would have been what? 7. Cool. This would have been 7. Right. Yeah. So from all these 3 states, you can either come back here or go up here or here. So this is also fine. So you can also be here, you can also be here, stay there itself, or you can be here. Now the way this is forming is, let me write it. So initially at t equals to 0 you were at 9 9, right? You were at 9 9 and then for t equals to 1, it became 8 to 10. Then for t equals to 2 it became what? It became 7 to 11, right? So if this was t equals to 0, if this was t equals to 0, and then this was t equals to 1, I guess you can really see a pattern forming here, right? T equals to 1, t equals to 2. Okay, so what do you see? For t equals to 0, you can say the guy can be in range 9 to 9. For t equals to 1, this guy can be in range 8 to 10. For t equals to 2, this guy can be in range 7 to 11. You can see here, he can be in any range in this, right? So for all the consecutive times, the current range is sort of, you can say, a superset of the previous range, right? So this question can be simply reframed as, if your current, you can say, current interval is this, this guy can actually fly at this altitude if there is an intersection between your current, you can say, at time t, right? So we have to find if whether at time ti we can be on a given altitude. So if at time ti, this is your allowed interval. So we'll come back to this. How can we find this? This is your allowed interval where you can fly. For example, time equal to 0, this guy can fly in this range. Time equals to 1, this guy can fly in this range. Time t equals to 2, this guy can fly in this range. If there is an overlap between your current allowed altitude and L of I and U of I, right? So if there is an intersection between these two guys, then you have, then yes, right? So there has to be, for all the possible ti, there has to be a overlap between these two guys, right? So for example, if this is let's say 7 and 11 and L and U is what, 8 to 10, then this is a valid answer, right? So what I'm saying is, guys, let me again be very explicit. So if this is, you can say, the interval where you can be at time of I, and your L and U is maybe, let's say, something, your L and U are something like this. Okay, your L and U are maybe something like this, or this, or this. So all these are like, if these are the possible intervals, that is what I'm trying to say is, if there is, you can say, a valid overlap, and so you know that L and U both are positive. If there is a valid overlap, you know that this guy's altitude is not going beyond 0, and if there is a valid overlap, for every possibility I, then your answer is yes. Right? Cool. Now all that you have to check is, now we know that initially your valid overlap, like so firstly I guess you know that initially your range is HH. Okay. And then for the first time, I guess you can easily check, right? So at T1, this will be what? This will be H plus T, H plus T of 1 if I'm talking about one based indexing. And this will be H minus T1, right? So H minus T1, fine. So now L1 and U1 has to have some overlap here, right? So let's just say for now there was overlap, something like this. Okay, so this was L1, this was L1, and this was L1, and this was U1. It's U1, right? So this overlap. So yeah, this guy can definitely be in range L1 to U1. Now, what you have to do is, now when you go to next guy, when you want to check for you can say T2, what is you can say like what is you can say the previous interval, or what is you can say the current interval of this guy when I consider T2. So you know that this is the interval where this guy can be H1 plus T1 and H minus T1. Now for the next guy, when I go to T2, this guy was previously in this range, right? So this guy was previously in this range, right? And now what you have to check is if this range is what this range, let me just call it again a left and a right? So for the next round, what you have to check is for this right, you will add some whatever the time has passed, some delta time, and from L you will subtract whatever the time has passed, some delta, right? So this, let me call it delta. Okay, and then you just have to check whether there is an overlap between this and L and U, right? So I'll just show you in the code. I guess it will make much more sense there. Okay, let me just show you my submissions. Okay, yeah, expand. Cool. So yeah, see, first take N and H as input, fine. Then the previous interval, you can say the previous interval is simply at the start of the guy is HH. Then this is what this is just the previous time instant, right? You know that the time instant is growing. T1 is less than T2 is less than, so on and so forth, right? Now this bool yes equals to true means initially I'm assuming that all the altitudes are possible. If somewhere I don't find a valid overlap, then fine, no overlap is possible. Okay, then I'll just update this yes to false. Okay, then I'm taking the input for a given time instant. I'm finding how much time has passed. Because I have the information of how much time has passed, I can update my current interval to be previous dot first minus delta, right? So H minus, so initially it will be H minus delta. So here, like initially delta will be what? T1 only, right? So H minus delta and H plus delta, right? In other words, previous dot left bound minus delta and previous dot right bound plus delta. Okay, and then I'll find the intersection. Now what is this? How do you find the intersection of two intervals? So if you have two intervals like this, you can say L1 R1 and L2 R2. You can say the intersection is max of L and min of R, right? So max of L and min of R. Okay, so you can just visualize it. If you want to find out you can say intersection between two intervals, you take the max of the left and min of the right. That's what you do. Okay, so then you find the intersection. Now this is a valid intersection if left is less than equals to right? So if it is not a valid intersection, I make yes equals to false, and then whatever I do doesn't really matter. But if it is a valid interval, then I will not make yes false, and then I'll just update my, you can say, previous, right? So this will be, you can say, used to calculate the next valid interval where this guy will be, and then I'll update previous time. Okay, so this is used to calculate the delta, right? And after this loop ends, I can just check if there was some altitude where this guy was not like if there are all the altitudes where this guy could have been, and if it is not possible, then we'll just print no. Notice that if there is a valid interval, you know that this altitude will always be positive, right? Why? Because L and U are positive. So if there is a valid intersection present between the current possible where this guy can be and what is the expected, then that will always be positive because of the fact that L and U are positive. Fine. So yeah, I mean that's about the third question. Now let's see. I hope I can bring the fourth one this time around.